Today's lesson is going to be about solving equations, systems of equations in three variables. I gave you an example of a system of equations of three variables right here. Ax plus by plus cz equals e, fx plus gy plus hz equals j, and kx plus ly plus mz equals n. The solution to this system is going to be an order triple with coordinates of x, y, and z. This order triple represents one point, which is the intersection of these equations, and all these equations, each individual one, represent a plane. So this one is one plane, this one is one plane, and this is a third plane. If they intersect at one point, that's when we are going to have one solution in the three-dimensional coordinate plane, which is called an order triple, x, y, and z. Here is an example of a system of equations of three variables. The first thing in solving this system, we are going to label the first equation A, the second one B, and the last one C. In solving these equations or systems of equations, we are going to use elimination or linear combination because that is much easier than using substitution when we have a larger system like this. So I'm going to first look at each one of the coefficients of x. If I look at x, the least common multiple for the three coefficients would be 2. Then I'm going to look at the y's and find the least common multiple for those, which is 12. And then I'm going to look at the coefficients of z and find the least common multiple, and the least common multiple here would be 3. So if I look at my x's and I'm looking at my z's, either one of them are pretty simple to use for elimination. What I'm going to do is I'm going to choose to use my x's. So the first thing I will do is multiply the equation A by -2 and add equation B to this -2 times A. So -2x plus 6y minus 2z will equal to -4. And the second equation I just write unchanged, which is 2x plus y minus z equals 5. Then I'm going to add these two equations, and I get 7y minus 3z, and that will equal to 1. I'm going to label this in equation D. Now I'm going to have to use another equation, one of A or B, and I also have to use C in order for me to be able to solve the system. So since we eliminated the x using two equations A and B, I'm going to eliminate x, but now I'm going to use equations A and C. So to do that, I'm going to say multiply A by -1 and add equation C to it. So -x plus 3y minus z will equal to -2, and x plus 4y plus 3z will equal to 13. So if I add these two equations, I'm going to have the x's cancel out, and I have 7y plus 2z equals 11. I'm going to label this equation E. So now the resulting system of 7y minus 3z equals 1 and 7y plus 2z equals 11 is a system where I only have two variables. So I'm going to write equation D under E, and Then I'm going to multiply equation E by -1. So -1 times equation E is -7y minus 2z equals -11. And I write D, equation D, unchanged, 7y minus 3z equals 1. If I add these two equations, I get -5z equals -10, and z will equal to 2. Once I have z, I can substitute this z into either E or D. So I'm going to substitute it into, let's say, E. So I'm going to say 7 times y plus 2 times 2 will give me 11. So 7y will give me 7. So y will give me 1. So now I have 2 of the coordinates in the order triple. So lastly, I can take y and z and substitute it into any of the original equations. So I'm going to choose A, and I'm going to substitute. So x minus 3 times 1 plus 2 will equal to 2. So x minus 3 plus 2 equals 2. X minus 1 equals 2. And x will equal to 3. So I just found my third coordinate of my order triple. So the solution to this system can be written as 3, 1, and 2. So this is going to be our final answer to the system. So here is our second example. And when I look at my coefficients of x or coefficients of y and coefficients of z, to me the easiest is to work with eliminating x again. So the first thing I start out with is labeling my equations A, B, and C. So I'm going to multiply A by -3, and I'm going to add it to B. So -3x minus 6y minus 9z will equal to -18, and 3x plus 7y plus 11z will equal to 22. If I add the two equations, I get y plus 2z equals 4. So this is my equation D. Then I will go ahead and multiply A by -5 and add C to it. So -5x minus 10y minus 15z will equal to -30, and 5x plus 12y plus 48z will equal to 125. So if I add these two equations, I end up having 2y plus 33z will equal to 95. So this will be my equation E. So I am going to place the two equations under one another. So I'll write D over here, and I right away will multiply D by -2. So I'm going to get -2y minus 4z equals -8. So if I add the two equations, I'm going to get 29z, and that will equal to 87. and 29 goes into 87 3 times. So our z coordinate of the order triple is 3. Then I'm going to take the 3 and go back, and I'm going to substitute it into d right here. So I'm going to have y plus 2 times 3 equals 4. So y will equal to -2. So I have my second part of my order triple. So lastly, I'm going to go back to equation A because that seems to be simplest. And I say x plus 2 times -2 plus 3 times 3 will equal to 6. So x minus 4 plus 9 equals 6. X plus 5 equals 6. So x will equal to 1. So our final coordinate of the order triple is 1. So it's 1, -2, and 3, which is the solution to this particular system. Have fun doing your homework.